Howdy everybody in YouTube land. What we have in front of us today is a Sony CD player model D-5. Now this was before they adopted the Discman brand name, and actually that one I think is the first portable CD player that was ever released by Sony. Anyways, I don't know if it was the actual first portable CD player, but I know that was the first one from Sony as far as I understand. Now, this one was sent to me for repair. I don't know exactly what's wrong with it yet. We need to find out. So before we do that, and actually, let's see. I believe this thing is center negative. I think it is. So that is a center negative player, which means we need... Alright, so we're going to turn our bench power supply on. We're going to set you up to like 6 volts. We're going to grab our multimeter. We're going to turn it on, because what we need to do is we need to actually measure this barrel plug, because I don't know what the situation is as far as which one's center positive. So we're going to do center. We'll figure out which one it is. It's that one right there. So that is going to be my negative connection. Alright, so we're going to plug you into the rear of here, wherever that plug is. So we have that, and then we have our alligator clip leads, which I've got one right there. I'm just going to gently connect you right here, and then I'm going to connect you right next to that. Now, if you got this backwards, guess it depends on the design of whatever it is you're working on, but I can't imagine it being a good thing. Okay, so that's all hooked up. Let's see what happens. We're going to press the play. Nothing. Completely dead. No power. And that might have been what we had going on. Actually, you know what? 9 volts, not 6. My bad. It needs to be 9 volts. Let's try that again. There we go. Now we got power. So we got 00. So we got to put a disc in it. Ooh, you know something right away? That laser is in the middle. That's supposed to be all the way over here. So that's a strong clue of what we potentially might have going on. Because, let me close this lid again, press play, I get 00, but there's no, that's not good. Okay, so what I'm going to do is I'm going to put you back in here, see what happens there. Play, no spin, no activity, no nothing. Nothing at all. Alright. So with the lid open, let's see what happens now. I'm going to see if I can't get my microphone up close to it, because I have this little microphone guy right here. So what I'm going to do is I'm going to put this microphone right next to you. Right here. Let's see if we can pick up the sound this thing's making. It's trying, but it makes a funny noise. So, something is up with that. Alright, so now it's time to take this guy apart and figure out what we got going on here, because we have no idea. I've not worked on one of these before, so I'm not entirely certain what I'm going to run into. So, without further ado, let's go ahead and get this guy apart. It's not wanting to come apart. Maybe we'll use this tool. Oh yeah, that looks fun. Yeah, that's what I'm looking forward to get apart. Okay. You know, I wonder, was this made during the capacitor plague? Like, with all of the caps going bad on it? I don't know. It's a good question. Alright, let's continue disassembly. Yeah, this does not look fun. Well, at least we know where they go. We have, let's see, starting from this side, we have red, white, like a peach, black, blue, gray. And we have two browns over here, which looks like SD spindle drive, or I don't know. There we go. The rest of this, though, I don't know if it comes out. Oh yeah, that laser has to come off. Sure does. Ooh, we got some caps in here. 1985. Whew, I didn't realize they were that old. Yeah, I say it that way, even though I'm basically the same age, but anyways. Alright, yeah, I'm just simply trying to figure out. Okay, so that ribbon's got to come off next. That's the tracking and focus servo. Yes, so we have all of that. There we go. We got to get you out. Another black, purple, white, and gray, brown. Yeah, these are not fun to take apart. So this is a... Oh, there's a lot of gears in here. There's a lot of gears in here. All right. Let me work on getting this apart and then we'll be back. All right, so before I get too carried away and taking that thing entirely all the way down to nothing, from what it sounds like is when I hit the power button, I'm getting that noise that I thought was the motor. Well, that noise sounds like it's coming from the DC to DC converter. So what I want to do is, first off, I want to look at the service manual here. I found the service manual. I want to look at the outputs of the DC to DC converter to make sure I don't see any shorts. So pin 1 is the drive output for the servos. So pin 1, it's fine. Let's see, pin 6, so 5 is ground. 1, 2, 3, 4, 5. That's right. And then 6 and 7 is positive and negative 5 volts. Fine. Ooh, that's a little low, but it is negative, so let me reverse the leads. It's fine. No, there's no shorts on that. So the DC to DC converter, why is it there? Well, I'll tell you why it's there. So for given variable inputs of your DC voltage, so if this was plugged into a battery, because it is designed to work with a battery, it's going to vary, right, as the voltage is draining and things like that. Well, in order In order to keep the CD player playing, you got to have a very, very stable servo voltage, stable reference voltage. All this stuff has to be stable. So the DC to DC converter ensures you have a nice, clean, perfectly stable output over a given input voltage. So that's important, because if that drifts, then you're going to lose lock on your servo when the battery gets low or something like that. So that's an issue. So what we're going to do now is we're going to go ahead and just energize this thing again, because I want to check to make sure I don't have any problems. Let's see, 2 is input. It's great. Okay, so I want to check the DC to DC converter when I go to try to fire this thing up, which is easier said than done because I need a ground point for my probe, which right now I'm just going to sneak you up over there for now, which is kind of hard to do. Yeah, because I need like 3 hands. Alright, make sure I have my voltage here, and I do. So this is the servo voltage out. Let me hit power. I got 9 volts there. And then it shut down. Okay, so let's check the positive and negative 5 volts. So that should be our positive 5 volts. No, we got a problem with the positive 5 volts. See that? So our negative 5 volts is present, our positive 5 volts is not present, and our servo is present. Alright. So our whining noise is coming from the DC to DC converter, and it's because we have no 5 volts, which is pin 6. That thing feeds a whole lot of circuits. So if I'm looking at the schematic, which you can't see right now, sorry about that. That runs the headphone amp, it runs, oh Lord, it runs all kinds of things. Yeah, it runs basically everything. Okay, so why don't we have a 5 volt output from the DC to DC converter? Well, your guess would be about as bad as mine at this point. I'm going to double verify. So this is our negative, so that's 7. That's good. Yeah, we are missing our 5 volt supply coming out of the converter. And it's screaming like there's a short. But I can measure. There's no short there. Let's do an ohms reading. Yeah, that's fine. That's negative. This is a positive rail. Yeah, there's no short on that rail. Okay, so all right. Yeah, it's not going to work. Anyways, all right. That's our problem right there, is we're missing our 5 volts. So the DC to DC converter module has to come off the board so we can try and figure out what's going on with that. Not entirely certain at this point, but we will figure it out. Alright, well, here's going to be your issue, is right there. I wonder if there's any, yeah, I'm going to find out if there's any caps in here. Oh, well, that's fun. They decided to seal this with freaking solder. What did we find behind door number 2? Yeah, that looks a little toasty. Well, that would explain why my 5-volt supply is not working. Oh boy, that's fun. Well, there's your problem. You can see where it got smokulated in that one. I took the transistor out and you can see the burn marks on the PCB. Also, the polymer, the little Sanyo polymer cap blew up too. That is catastrophic failure, but I don't see any shorts. I don't know what happened exactly. That's not shorted either. It's open, but it's not shorted. So that's kind of curious to me. That's weird. I do not know why this failed. It definitely failed, but why is a huge unknown. Alright, so I took the other inductor off the board, so both of them are off. The original inductor that was in the circuit that got damaged, it's only reading 12 microhenries, which is not, that doesn't sound right. So I pulled the other one out and it's reading 150 microhenries, which is about where it should be. So since this is negative 5 volts and that's positive 5 volts, they should be even. So this 150 microhenry inductor is reading 12 microhenries. So I decided to pull out the ring tester and yeah, it's dead. There's no rings whatsoever. Where that inductor here, the good one, rings just fine. Like so. Yep. Alright, so the inductor is dead too. So we need to replace all three of those components. Now I got to figure out what this is. It's 150 microhenry, but I don't know what amperage rating it's for. This transistor has a 5 amp collector current, but there's no way this circuit handles 5 amps. So I'm going to say that's like 1 to 2 amps, potentially, of a, I don't know. We'll figure that out. Alright, so here's our casualties so far. We have the transistor, which is bad. We have the main inductor, which is bad, and it appears to be 150 microhenry. I don't know the current rating. If I look up 1 amp, it's too big and tall to fit in here, so this is probably like a half amp or something. I'm not sure. That's open, and these two filter chokes are shorted as well. And I had to pull a good one off the board to measure it out, and these are 60 microhenry with a very low Q, low ring count. These don't ring at all, they're shot, and they read like 12 microhenry once again, which means it's shorted. So that's where we are right now. So I'm gonna have to spec all of those parts out and get them ordered. But that begs the question, why did this happen? I did some Googling, and I've seen forum posts where people have had these blown, but even worse. Is it because of reverse polarity? Someone plugged in the wrong plug? Or what is it? Don't know. But it's definitely a problem, so we have to get it fixed. Alright, well, all of the parts are here for this thing now. So we've got this is the transistor that I'm going to attempt to use to substitute. Hopefully that works properly. That's what I spec'd out for the inductor. The microhenries rating is about where my measurements are for the good one, but it's the current consumption. I don't know if that's going to be accurate or not, but we'll find out based on how it performs. We have our 16 volt 22 microfarad polymer cap to replace the one that's completely burnt open there, when that should be good. And we have a 68 microhenry inductor, which I think these are just a filter choke, which goes like in these two spots there. So hopefully it works. So what I'm going to do is I'm going to put the parts in here first. Then I think what I'm going to do is put it on the bench supply by itself, just wiring up these pins, and that just run the power supply, open like that to make sure my voltages are accurate before I go through the trouble of putting it back on the main board here and causing any further issues. So, story of my life strikes again. I did run into a small issue. So that transistor's too tall, because when that transistor is sticking up in there, it won't go on this can anymore. So when I was speccing out all these other parts, which was super important to get the inductor heights and capacitor heights and stuff right. I totally forgot about the transistor height. And it's hard to get, matter of fact, it's impossible to get these particular patches or packages anymore that aren't surface mount. So, yeah, anyways. Alright, so now that that is done, we have to get that board hooked up onto the power supply over there. Actually, I need to get this into DC volts mode. And fire this guy up and see what happens. But all the parts are in there. I got the 2 filter choke inductors in there. I got the main inductor in there. And I got a polymer capacitor in there. And hackishly, I got that transistor in there. But there's not a whole lot I can do about that because it's just too tall. It would have stuck way out there. So, it's unfortunate. But so if one of these other transistors goes bad, I'd really have to research replacements. Grab the phone because it's easier to hold while doing this. So I got a Zener diode in here to drop the voltage. So I got my 9 volts in. I got a 5.1 volt Zener diode so we can get the enable pin. So there is our reference voltage, 2.4 volts. Here's our negative 5 volts, which always worked, and we're good. Here's our positive 5 volts, and we are good. So the DC-DC converter is running. Yes. Don't know what it's going to do under load. That's yet to be determined. But I have a good feeling about it. So let's get this all put back in the CD player and let's see what happens. Alright, so we're kind of loosely back together here. DC converter is in. Here we go. Is it going to work or is it not? Let's see. See if the laser will return itself back home. Oh my God, it works. It works. Okay. Now, let's grab this totally inconspicuous disc and see what happens. It's playing. It is actually playing. Holy crap. Wow, okay. Does it go to the last track? I don't know if it will or not. These things are not very good with CDRs. I'm amazing it's working at all. It is. It is playing. Alright, so just when I thought this was fixed, we take another step back. So I noticed while this was playing that it stopped on me and showed me a 00. And I thought the DC converter went bad. So I shut it off, turned it back on. I noticed the battery light was on. I'm like, that's weird. So I turned it back on, pressed play, and it was playing, and then it shut off again, and the screen got real dim. So I'm thinking, that's weird. So I shut it off again, and I decided to take a closer look at this, and come to find out, there's a separate voltage regulator, which I might have picked up on that before, I don't remember, that powers the microcontroller unit. So I'm thinking, okay, so what I've done is, I wanted to watch the 5 volt supply as this thing runs, just because I have a suspicion that's what it is. So I tapped it right there, and I got the ground probe just connected over here on the main ground, which is the same as that. And I turned the power on. Look at this. We're running way up here in the 8.2 volt category. That's not good. I'm surprised it didn't destroy the microcontroller, because that's bad. It falls down when I press play. But you see that? It's just no. That regulator's bad. So you know what that tells me is the reason why this DC-DC converter died is I bet you someone has installed the wrong charger in here with the wrong polarity, because look, it's center negative. And someone probably put a center charger, positive charger in here and damaged all this. That's why that was blown up, and that's why IC 802 is damaged. So we have another bad regulator. Unfortunately, I went through my stash and I do not have those style of 5-volt regulators. And it goes right there. So the show must go on. I need to make sure this thing works. I'm going to have to get those parts on order. But in the meantime, I'm going to steal one from over here. So this is an old parts board that I've been stealing parts off of. So I've got a little 5-volt regulator right here. It's not the right one, but I think I can just kind of fudge it in there for now, just for testing, to make sure that there are no other faults with the system before I start going down the road with this. So that way I can ensure the stability of the player, make sure everything else works, and I have no more malfunctions until I can get the new parts in. Something kind of like that. So I'm grounded, then I have my output, and then I have my input. So, yeah. Not the best thing in the world. Plus, I'm on the other side of the fuse, so I'm living a little bit dangerously here. But, hell, I was living dangerously with the system stuck with 8 volts on a 5-volt source. So, yeah. Alright. Let's fire this thing up and see what happens. I also spritz this a little bit with deoxit so I can work that in there, because it was very, very noisy. Yeah, that's much better. And we're playing again. So I'm going to go ahead and let this run. And hopefully we have no more issues. It played that CDR amazingly well. Twice in a row. Now I'm going to try an actual pressed disc. So this is the very first music CD I've ever owned in my entire life. This is it. When I was a kid. And that's the CD that I got at the music store after I had fixed the CD player when I was 9 years old. So, yeah, there we go. I still have the disc. So, hopefully, that works really well. It should. Picked it right up. Alright, so now that the regulator has arrived, there's the new substitute part number from the original, because the original is no longer available. That should work. We're going to find out. But, yeah, so now that that is taken care of, let's get this thing put back together properly. So I'm going to get that put in there and get this bodge regulator out of there. And hopefully we can finally wrap this project up, get it off my bench, and move on to the next one. Alright, so the new regulator has been reinstalled. Now, judging by the amount of damage this thing had, there's no doubt that someone plugged the wrong polarity or wrong type of charger in there. So, how are we going to fix that from ever happening again? Well, what we're going to do is we're going to install a Schottky barrier diode, so right across this DC jack. So if someone plugs a positive center adapter in, it's just going to short circuit the connection, so it doesn't hopefully damage the CD player again. So I got a bunch of these Schottky barrier diodes on hand from years ago, back from when I was in college. I used to work on a contract job with a AV audiovisual company, and they were sending me InFocus LP 320, 340 series power supplies by the dozens because they were blowing up. And I was rebuilding those, and I had so many of these parts left over from doing that. I ended up quit doing that, plus the crash of '08 was looming. And anyway, so moving right along, I still have a bunch of these parts left over, so we're going to use that, somehow fit that in there, finagle it in there, and see if we can't solve that problem once and for all. Then we're going to put it back together. Perfect? No, but that should stop that happening again. And it's a high enough current diode that if incorrect power supply were to be plugged in there, it'll shut down the power supply before it actually shorts that diode. At least that's the hope anyways. So, alright, it's time to start putting this guy back together, and we're going to do one final test. Hopefully you enjoyed this video. Don't forget to hit the like and subscribe and all of that fun stuff. If you have a comment, please feel free to leave one. Until next time, guys, thank you for watching.